If you're into 3D printing, you know that open source is a hot topic right now. Bamboo Labs tried to stop a developer from using some of their code in an open source slicer, and it blew up into something I think much bigger than they expected. And it's interesting because 3D printing started out, at least the home 3D printing started out open source. And the Ender 3 was one of the first open source Chinese printers. And because of that, you can still get parts for these. You can use one on Facebook Marketplace, update the firmware, update the bed, update the parts, because it's all open source, and bring it back to life. And the same thing happened in electronics. Microchip many years ago produced the PICkit2 Programmer for hobbyists to work with microcontrollers. But then they stopped producing it and went on to the PICkit3, PICkit4, PICkit5. But they open sourced the PICkit2, so clones came out. So now you can keep getting a PICkit2, either the original or a clone. But the software was limited, so you couldn't program all the latest devices. Well, that changed too. Because of its open source nature, it was able to expand. So now you've got software for all these guys that can program all the latest devices. And because of that, you save money on buying the components, which will help pay for the software that allows you to use your open source programmer. So open source saved this path for hobbyists to program little 8-bit microcontrollers. And I'll explain you more about it right here at Chuck Hollowbuck's Electronic Products. Now, many people have asked me, why do I keep pushing the PICkit2? And I'm not pushing it. You can use any programmer you want. In fact, there's a low-cost programmer called the MPLAB Snap. There's also an MPLAB Basic. There's a lot of low-cost programmers out there from Microchip to kind of get back into that hobbyist market. But the PICkit2, to me, is still the best answer because this is a high-voltage, low-voltage programmer where this is strictly a low voltage, meaning there's certain things you can't do unless you have the high-voltage programmer. And that's what PICkit2 does. Now, if you want the latest and greatest PICkit5, go for it. I think they're about $80 or $70. And that'll program both PICs and AVRs. So there are advantages to that. But you've got to download a whole MPLABX environment because all the code is embedded in there. So you're going to download a bunch of code for an IDE that you may not even want. So it's taking up space in your hard drive. For the PICkit2 is really simple. It's an independent application to drive it. And it's got other features like a built-in serial terminal. It's got a logic analyzer and a few other features that this program won't have. So I still like the PICkit2, and the fact that it's open source, you can build your own just like I did. And I even 3D printed my own case to make it the way I wanted. But one of the best clones out there that I see is the one from PICCIRCUIT.com. I use these all the time, and you don't need cables because it comes with the connector that goes right into the USB port, and then this connects to your circuit board, the 6-pin header of the board, just like that. So you don't need extra cables, it's all contained. And that's what happens with open source. People take the open source design, let PICkit2, and make it better. Years ago, Microchip released the PICkit2 Starter Kit, which included a PICkit2 programmer, a development board, and a PIC16F690, a 20-pin microcontroller. But they discontinued this, but open sourced it, which is what I showed in a previous video where I reproduced the board. We have the PICkit2 clones. I made a 3D print to hold everything, including a breadboard. So now you've got the PICkit2 Starter Kit. In my previous video, I supplied all those files, and if you go to PCBWay.com, for $5, you can get 10 boards plus shipping. You just upload the Gerber files into their system, give it all the features that you want, like what color silk screen, what color solder mask, and they'll give you an instant quote right up here on the side. In my case, it's $22.76 to ship to me in Michigan, so a total of $27.76 to get 10 boards. So it's pretty cheap. And then if you want them to assemble it, they've got assembly services as well. You go in there, you can give them a kit of parts, or you can do turnkey, give them a parts list, they'll find the parts. It's going to cost you a little more for that, but it makes it easier if you want to build a bunch of these or you got a product you want to build. They also offer 3D printing service, CNC machining, and sheet metal fabrication. You can get all that done at PCBWay.com. So check them out, our sponsor today, PCBWay.com. But what do you want to use for the 20-pin part? Now this supports 8, 14, and 20-pin devices, but what if you want to use the latest microcontroller instead of the PIC16F690, which you can still get this, but they recommend the 16F18344 to replace it, which is another 20-pin device. And this one, if you buy 25-piece quantity, is 73 cents cheaper than this one. And so if you bought 25 of these instead of 25 of these, you'd save $19. So if you got a product you're trying to produce, $19 you're saving on microcontrollers. There's one problem. If you have this original kit and the software, it doesn't support the latest devices. Even if you've got the clone and everything, it doesn't support the latest devices. That's where PICkit Plus comes in. It allows you to program these latest devices for only $14. And because you saved $19 buying this chip instead of this and a 25-piece quantity, it paid for itself, plus you got $5 in your pocket. So this is where open source allowed the PICkit2 starter kit to continue. You can use the latest devices and program it with updated latest software with the PICkit2 Plus. Open source allowed all that to happen. And it wasn't just the 20-pin devices, the 8, 14, 28, 40-pin, there's a whole bunch of new ones that you can now get much cheaper than the originals and still program it with your original PICkit2, your own PICkit2, a clone PICkit2, without having to buy a new programmer. All because open source allowed you to access all that with new software called PICkit Plus. And it's made by the same guys who make the GCBASIC compiler that I love that produces pure assembly code. And it takes a very little space in your hard drive. It's got its own IDE, the latest type of IDE through VS Code. So you've got a lot of the latest tools to develop your little 8-bit microcontroller designs, something you may interface to your ESP32 or your PICkIT or build it in as a sensor to your robot, or even make some small product with a low-cost 8-bit microcontroller. Now, if you want to do 32-bit, go for it. What I'm saying is this another tool in your toolbox. But because of open source, both the hardware and the software, I can use all these same tools that I've been using for years and not get left behind. So I'll just do a quick demonstration. Now this has an 8-pin microcontroller in its socket, so I need to make a jumper from RA4 over to RC0 to connect to the LED. Then I'll plug in the PICkit2 clone programmer right into the USB port. And now on my Windows laptop, I've got the free VS Code based GC Studio that runs the GCBASIC compiler. I select the PIC12F683, which is the 8-pin part I've got in the socket. Then I'm going to send a pulse out that RA4 pin, GPIO4, at 100 milliseconds. And then I'll delay 900 milliseconds before we loop back in a do loop and send another pulse. So it's basically going to make the LED blink. I use the auto import feature in the PICkit software, so when that file compiled, it automatically programmed the device, and there's the LED blinking on the board. All controlled by the little 8-pin, 8-bit microcontroller. And now I'm ready to do more complex projects. And this is why I love open source, because I can still use my Ender 3s, get updated beds for them, get updated firmware for them. I even use my mostly open source Prusa printers back here, and I love them. So it's a nice combination, and I can 3D print my own cases for my own open source programmers. And I don't say everything has to be open source. Companies need to protect some things. There's no doubt about it, so they can keep their business going. But in a case where you're using open source software, like in the case of Bamboo, you got to recognize you got to share backwards. And that's what Microchip did. They haven't fought this. People have made clones. They haven't fought it. I haven't seen Creality fight this at all, open source. So the fact that open source lives on more in the future than the present, that's what I love most about open source. What do you think about open source? Let me know in the comments below. I want to give a big thank you to the main supporters of this channel, my Patreon supporters. Thank you so much for everything you do. Thanks for watching. And if you like what I'm doing here, maybe check out some of the other videos popping up. If you want to help support the channel, Patreon's the best way to do it. And if nothing else, click on that CHEP logo and subscribe. I'll see you next time right here at Chuck Hullabuck's Electronic Products.